everyone. Welcome to Study Guide Forum. Today we'll be looking at how to calculate the limiting reagent or limiting reactants and SS reactants in a chemical reaction. Actually, this has to do with stoichiometry, and more of it is that is a practical application of stoichiometric relationship between reactants and products. Now, what is the limiting reagents or reactants? This is the reaction. This is the reactants or reagent that get consumed entirely in a chemical reaction. You know, in most cases, when you are doing your experiment, perhaps maybe you did not consider the stoichiometric relationship in the experiment. You find out that one of the reactants is likely to be consumed before the experiment will end, whilst one of them will also remain. And the one that remains in excess is what we call the SS reagent or SS reactant. This is the one that will continue to react as long as the other reagents is still available, or the reactants. So in this case, the limiting reagent tends to stop the reaction because it determines the kind of product that it determines what is to be produced. So while we talk about the limiting reagent, which determines, or maybe determines how long the reaction will stay, because as long as the limiting reagent is exhausted, the reaction will stop. Every other thing will stop. While the remaining one, the excess of the reactants will remain. So in this case, we're going to look at it. How can we determine it from a balanced chemical equation, or looking at the stoichiometric ratio of a chemical reaction? Now, how can we do this? So that's what we're going to look at briefly. We're going to briefly look at it. For example, let's say that we have a company that produces tricycle, and assuming that everything about the production of the tricycle remain constant except the wheel. Let's say the wheel and the steering. The steering is what we need to provide. And in this company, and they have 250 steerings, and then they have 600 wheels. Now, if something like this happens, it means that you know that for a tricycle needs what? 3 wheels and a steering to complete the whole production. For one tricycle, it needs 3 wheels and one circle. That is to say, and one steering. That is to say, 3 wheels plus one steering will give us one tricycle. I can say that this is a balanced equation on that. Talking about this is their stoichiometric ratio, as the case may be. And in this case, now we know that 3 wheels and one steering will give us one tricycle. Now, we are to find out the one that will get the material that will get exhausted at the start of the experiment, or the production. Let's say the production. Now, when we are producing that, one of them will get finished first, while the other one will remain. So to get the one that gets finished first, now what we're going to do, we are going to find out the number of tricycle that will be produced by what? This very one, the wheels. And then we look at again the number of tricycles that will be produced by what? The steerings. So in this case, what we're going to do here, since we know we have 600 wheels, it means that 600 wheels from our relationship or stoichiometric ratio, as we all know in chemical reaction. so so we can say that um, three wheels, three wheels will give us one tricycle, and then 600 wheels will then give us 1 over 3 times 600 over 1. 3 will cancel out, this will cancel, we have 200 tricycles. This is that means now what we will get from this is what 200 tricycles. That is what we have here. For 600 is equal to what? 200 tricycles. So another one we're going to look at is to find the number of tricycles that we produce when we use 250 steerings. So what we do here again is we'll come over here. We say that since you have one steering is equal to one tricycle. We have one tricycle there. One tricycle. Oh, what am I writing, sir? One tricycle. So 250 steering will give us the same 250 tricycles. 250 tricycles. That is what we're going to get if we if we are to use all the 250 steerings. Now, when we look at this now, we find out that for the both of them, merely looking at them, we find out that while we are going to produce 250 tricycle from 250 steerings, in 600 wheels, we are going to produce 200 tricycles. So in this case now, the limiting material here, is what? The wheels. The wheels is the limiting material. That's this one. Because by the time you produce 200 tricycles, there will be no more wheels to use up the 50 that's remaining. So in this case now, we say that for the fact that this one is the wheel produce the least, we say is what? The limiting material. In the same way, that's in chemical reaction too. So in chemical reaction, that is how we come about that. So in this case again, let's say if you are going to find out the one that will be in essence the material that will remain, at this at the end of the reaction, it will mean that what it means here is that since from what we have here, the number of wheels that will be required in producing 200 tricycles is just 200 wheels. So in that case, the excess of the steering will be 250 minus 200. That will give us 50 steerings. 50 steerings. That is the excess of it. So in this case now, having gone through this one, we are going to look at it, apply the same idea or principle in chemical reaction. That's what we're going to do here. We're going to look at how to produce some other substances in the lab, and then we'll look at how we'll be able to identify the excess and the limiting reagents. So here we're going to be looking at the what happened here in preparation of ammonia in Haber process. In this case, the question says we are given what 10 cm cube of nitrogen, and it combined with hydrogen. That is, we combine with 20 cm cube of hydrogen. 20 cm cube. I made a mistake here. 20 cm cube of hydrogen. 20 cm cube of hydrogen combined with 20 cm cube of hydrogen to produce ammonia gas. They calculate the limiting reagents. and then the volume of excess reagents. Now we have the chemical equation. From the chemical equation, one thing about this thing being that it has to do with stoichiometric relationship between reactant and the product, you need to really consider the stoichiometric ratio of all each of the um, reactions. Now we can also, the first thing we do to limit to get this thing is to find out the moles. It's either you work in moles or you get the mass or you get the volume of ammonia produced. The one that produce the least is the one that is the limiting reagent. Each of them, two of them, the one that produce the least volume of ammonia is the limiting reagent. So in this case now, let's do this. In order to calculate this the limiting reagents, what we do here is that we check, we calculate, we find out the volume of each of them, volume of ammonia that can be produced from each of them. Now what we do here is that we know from this reaction, nitrogen has a, can say that 1 cm cube of what? Nitrogen will give us 2 cm cube of what? Ammonia gas. So from what we have here, then 10 cm cube of nitrogen will give us 2/1 times 10 of ammonia. That will give us 20 cm cube of what? Ammonia. 20 cm cube of ammonia. That is 20 cm cube now of ammonia gas. So that is what we have there. So in this case now we look at how many volumes that can be produced by the hydrogen. In the case of the hydrogen, what we have here is that from this chemical balanced chemical equation, we say that 3 cm cube of hydrogen will give us 2 cm cube of what? Ammonia. So what do we have here? We have 20 cm cube of hydrogen will give us then 2/3 times 20/1. That will give us 13.1 cm cube of what? Of ammonia gas. That is what we get here. So looking at this now, since this one produce high volume of ammonia and this one produce the least, that means this one is the what? The limiting reagent. Now the next thing we're going to find out is how do we get the volume of the excess reagents? That's another question now that we're going to look at. How do we get the volume of the excess reagents? Now we have know that this volume of ammonia we produce, and then we know that this other volume nitrogen will produce this. Now what we do here to get this thing done, you need to find out the volume of nitrogen that can react with this volume, the volume of the limiting reagents. Volume of nitrogen that can react with this 20 cm cube will be able to help us to know the remaining volume of this thing that might not react, of this nitrogen out of this 10 cm cube, the one that will not react actually. So that's what we're going to do now in this case. So we come back here. Now what we do here to calculate this, we know that from this reaction, we know that 10 cm is 3 cm cube of hydrogen will give us, we combine with, we react with 1 cm cube of what? Nitrogen. Then since we have 20 cm cube of this, 20 cm cube of hydrogen will then react with 1/3 times 20/1. That will give us, when we divide it through, we will have something that look like this: 6.7 cm cube of what? Nitrogen, of nitrogen. That is what we get. So in this case, it means that 6.7 cm cube of nitrogen will combine completely with this to give us that volume of ammonia we need, which is about 13.3. That will give us, both of them will combine to give us 13.3 cm cube of 3 cm cube of what? Ammonia. So in this case now, since you have been able to find out that is the volume that will react, now the volume of excess reagent. The volume of excess reagent means that this volume 10 cm cube in this 10 cm cube, not all of them will react. In that case, we say that 10 cm cube volume of, let's say volume of excess reagent will then be 10 cm cube minus 6.7 cm cube. That will give us about 3.3 cm cube of what? Nitrogen, which will not react. That means the excess of the reagent is what? This. So thank you so much for being part of this, and we hope to hear from you via the comment section. Thank you.